All right. Thank you for coming. I'm Sital. I'm doing a PhD in University of Illinois at Urbana-Champaign, and I'm a JSPS fellow here at Duke University. So today I'll be talking about my PhD research, which is basically water sanitation and hygiene work we have done in Nepal after the 2015 earthquake. Just to give a little bit of background, the 2015 Nepal earthquake happened in May of, the main earthquake happened in April 25th of 2015 with a magnitude of 7.8 Richter scale. And then right after that, less than a month after that, we had a second earthquake around the same epicenter of magnitude of 7.3 on May 12th of 2015. As you can see, the mostly affected areas were around the capital city, Kathmandu, and the cities around it. Just to give a brief background on how the disaster was, it affected a lot of places, including the villages on the upper right-hand side, the structures, the concrete structure on the left side, the old houses, and historical buildings as well. So there was a lot of destruction all over the places and all kind of building structures. Just to look at the numbers and how the damage was, there were more than 510,000 houses destroyed. 200 or almost 300,000 houses partially destroyed. Around 17,000 people were severely injured, and there were 2.8 million people in need of humanitarian assistance. And on top of that, there were more than 8,800 deaths because of the earthquake, direct deaths because of the earthquake. So the reason we did the study was mostly of the motivation was there was an 80% increase in communicable diseases right after the earthquake, as the Department of Health Services reported. Also, we have seen a case in Haiti after 2010 earthquake where there was a lot of cases of diarrheal diseases, and a lot of people lost their life because of that as well. So we wanted to see how the dynamics of water microbiome changes after the earthquake. So what we're looking for in the research was to identify if there was any change in microbial communities before and after the earthquake. Then we're focusing on the microbes responsible for geobiochemical characteristics of the water. So basically what this means is the microbes are responsible to maintain the stability of the water. If these microbes change, then stability of the water itself changes. And we had two areas to do the study. One was the affected region and one was the control region. So this is the sampling location and period. So our first site was in Kathmandu, which is heavily affected by the earthquake, and our second site was in Chapa, which is not very much affected by the earthquake. We collected the samples before the earthquake in 2014, May, June, July, and August, and we collected the samples right after the earthquake in May, June, July, and August of 2015. We also collected a sample in December in Kathmandu to see how it changes with time. So just to reiterate the whole thing, we had two sites, Kathmandu affected site, Chapa not affected site, and we had collected samples before and after the earthquake. So the way we did the study was we collected the water samples, we pre-filtered it with 1.6 micron membrane, then we filtered using the 0.45 micron membranes. We did the genome extraction for DNA, and then we did the qPCR, which is quantitative polymerase chain reaction, to see if we have fecal contamination from humans or cows. And then we did the 16S RNA sequencing, which talks about the microbial community structure of the water samples we collected. Just to give a brief background, so the way you read this map is like where you read the map itself. So if the 2 points are close to each other, means that they have very similar microbial community. If they are further from each other, means they have a different microbial community. The S samples represent the samples from Kathmandu, and the J samples represent the samples from Chapa. So we can see that all the Chapa samples are clustered in one region over there, which means that the microbial community of the Chapa samples are very similar. Whereas the Kathmandu samples, even before the earthquake, they were clustered in different regions, basically telling a story that even before the earthquake, the microbial communities were not very similar. So this is before the earthquake. So what we did was we analyzed the samples right after the earthquake. So what happens is over here, especially if you look at this figure over here, the green one. So S21 basically means the sample site 2 in Kathmandu. 1 is before the earthquake. So the inverted red triangle means the sample site 2 before the earthquake. And the green one over here is sample site 2, and the 2 means after the earthquake. So you can see that before the earthquake, the microbial community structure of the samples collected in this site was very, very similar. But right after the earthquake, it changed a lot, which means that there were more pathogens or more microbes detected right after the earthquake. So the similar structures were seen in more or less all of the Kathmandu samples, but not in the Chapa samples. To make the diagram more clear over here, so we did the comparison of microbial community samples collected in May 2014 and May 2015. Just keep in mind that the earthquake happened in April 2015, so we're trying to compare the microbial communities before and after the earthquake. So when we did that, Again, the S samples are the Kathmandu samples and the J samples are the Chapa samples. Like I mentioned earlier, if the samples are further away from each other, it means that the community has changed drastically. If the samples are closer to each other, it means the sub-community has not changed that much. So we did see a lot of changes in the Kathmandu community, but not so much change in the Chapa communities. So there was less than a one-fold change in the most of the microbes we looked at in the Chapa community, but in Kathmandu community, the fold was a lot higher, basically saying that the microbial community was not as stable in the Kathmandu samples compared to the Chapa samples right after the earthquake. Just to talk about these in numbers, so these are the few bacteria we looked at. So fold change basically talks about what was the percentage of that microbe before the earthquake and what was the percentage of that microbe after the earthquake. You can see that in Kathmandu samples, both S2 and S5, for example, if you look at disulfibria, which is responsive for maintaining the sulfur in the water itself, before the earthquake, the percentage of that bacteria was 0.08% of the total microbial community. But after the earthquake, it was changed to 4.71% of the total microbial community, which talks a lot about how the water was not as stable as it was before, right after the earthquake. And the reason we think this was happening is because of the influx of the people. So the samples we took was in the schools. And there were a lot of people moving the schools as temporary sites. So there was a lot of human activities going on, and there was a lot of stress on the water source they were using. So we think that was the main reason for this. Just to make sure that this was not a regular trend, we tried to see if we can see the same, if we see the same changes in seasonal variation. This means that it was not because of the earthquake. So to back our data more scientifically, we looked at the changes in microbial community in May and July of 2015. Just keep in mind that this is after the earthquake. Both the sampling points are after the earthquake. After the earthquake, we did see some change in the bacteria, but it was not as drastic change as we saw between the samples we collected in May 2014 and May 2015. Just to give an example, you can look at disulfibria, which we saw the big change earlier. It changed from 4.71% of the total microbial community to 4.93% of the total microbial community, which means that it did change a little bit, but it was not like 598-fold like we saw earlier. Also, we did detect a lot of, so fecal source tracking basically talks about the detection of human and animal feces in the water. So batch 1 is the before the earthquake, batch 2 right after the earthquake, and batch 3 8 months after the earthquake. We saw that the markers were detected more right after the earthquake, and it went back to its original condition 8 months after the earthquake, basically saying that there was a lot of sanitation issues right after the earthquake in the sampling sites. This again talks about the same thing I talked about earlier. There was an increase in the microbial community, abundance of microbial community we looked at right after the earthquake, and in December of 2015, 8 months after the earthquake, it went back. It was trying to go back to its original condition for most of the pathogens we looked at. So basically, this talks about the disruption of environmental microbiome after an earthquake and restoration of these microbial communities as a function of time and sanitation practices. Like I said, there was a lot of influx of humans, or the influx of a new population in the sampling sites. So increase in human activities could result in disruption of microbiome. We're trying to do the same study in Ecuador after the 2016 earthquake. So the other study we did was we did a lot of surveys to understand if people were getting enough water sanitation hygiene supplies after the earthquake. We wanted to know how survived the scope, particularly the positive, unique, and negative responses related to access of water, sanitation, and hygiene. For this, we used a Penn3 model developed by Penn State University. I'll talk about that in a little bit. For this, we did our surveys in Bhaktapur and Kavirpalanchak, which is both heavily affected by the earthquake. For one site, we did the focus group discussion, and for the other side, we did in-depth household interviews. So the Penn3 model talks about, it is a model started to use to understand the effectiveness of HIV rapid test kit in Africa. That's how this model started. But we use the cultural empowerment model over here to know the positive, negative, and unique responses to understand the problem in a different perspective. So there were a lot of positive responses of WASH right after the earthquake, surprisingly. So a lot of people said that they received water on daily basis after the earthquake, which is not a case before the earthquake, so they didn't have to think about water and water problem, at least right after the earthquake. Also, they were talking about how supportive the community was. Like the second response, we did not have enough water from the well before the earthquake, but now we're satisfied as our neighbor is giving to us free and it's closer to our temporary settlement. Also, a lot of people were happy that their toilets being constructed after the earthquake, which is not a case right before the earthquake. So this basically talks about even in adversities, the individuals have different levels of responses, which can be either from community compassion or external help from different organizations. These empowerment responses allow the communities to be more resilient and help with the coping process. The unique response we saw was mostly related to the supplies they're receiving. So few of the respondents talked about the chlorine tablets they got after the earthquake, which is really useful for them, so they didn't have to boil the water anymore. But again, there was issue with the education part of distributing the wash supply. So the third response talks about how they provided the chlorine tablets, but I'm not exactly sure how to use it. They taught us how many tablets to use for 5-liter vessel, not for 20 liters. So small issues like this were very unique and very interesting in the observation. So this basically talks about how changes in household sanitation practices may be short-term, depending either on continuous availability of supplies or willingness to use it in the future. Having continuous education on sanitation practices after an earthquake may encourage individuals to have better sanitation behavior. As expected, there are a bunch of negative responses to WASH, mostly about toilets. Houses around the camps are not very open with letting the people in the camp use the toilets. So we serve it in different places, so we got different responses from different areas. We saw that a lot. So females complained a lot about walking a mile or so to find an area away from the camp to use a toilet. Like the second response, is easier for males to just to do their business anywhere. It's hard for us who have to wait till dark and walk about a mile. The new toilets NGOs are constructing are not usable because water keeps coming out of the pit. They have just dug a hole near the temporary settlement. So most of the responses related to WASH was not on the supply of the water itself, but the sanitation and the access to the toilet. So we kind of concluded that results indicated the women in household faced a serious challenge with WASH after the 2015 earthquake. So to conclude this one, we used the cultural empowerment domain of PIN3 model. We not only highlighted the positive and negative responses, but also unique responses. We hope that these findings have implications for studies focused on building community resilience in aftermath of disasters. And also this study will not only benefit from addressing negative consequences, but also talking about the positive consequences to help people thrive and survive in extreme natural events. Both of these studies are published. So you can check out, both of them studies are published. One is published in Earthquake Spectra, and the other is published in Frontiers of Microbiology. So I'll be happy to take any more questions for 3 minutes. Thank you.
After the earthquake, I would like to know how the residents get help from this project.
How the residents get help from the project. So this is just a study. So N4 is the NGO we're working with. So they were the one responsible for supplying the sanitation, like buckets, soaps, and things like that. So they just asked our help to see if the people are happy or not. So with these kind of responses, what we're expecting is to for the next, if there is an event like this, for the next event, people will be more careful about. Think about like women's access to toilet, or be more careful about constructing a toilet in a nice way so it does not leak like they say right after the construction. So this is a recommendation we can give to our collaborators, saying that if we do this in the future, it might be more effective, especially thinking women's perspective in mind.
Okay. Because I saw one something like a comment from the residents that they are worrying about if this project is finished, whether they can continuously get the.
That's true. Because the main goal of the temporary WASH campaign is to make sure there is no outbreaks during a short period of time. So that's when a lot of outbreak happens few months right after the earthquake. So they cannot sustain providing the chlorine tablets for a long time. But a lot of people did not have an intention to using it after the earthquake. They were either not going to use it like before or going to just boil the water. Yeah, thank you.